Every piece of technology has its own risks, and containers are no exception. One of the first introductions that you might find interesting to read on Docker and Docker security is some posts by Adrian Mouat, who also wrote a pretty nice book using Docker, and that's pretty accessible. He was one of the earlier guys to write deeply on this, and he is the chief scientist of a container consulting company, which is run by a couple of Scottish people, so that's why I always say it's Container Solutions. Anyway, nice guys, they run great meetups. A couple of examples. If a container can sort of crash the operating system that it's running on, it will crash all the other containers on that same operating system, which is not as it will happen in virtual machines. Then it's probably easier from one container to have a denial of service attack to another container running on the same host. And if you can break out of the container, because the isolation is in the operating system rather than the hypervisor, if you're root on the container or admin, then after that breakout you will be admin on the host, which is definitely a threat vector. Then you have your potential for poisoned images. How do you know that the image that you run actually is what it is, etc. And finally, you will have a lot of server and to service and server to server communication that requires credentials. How do you deploy these if we're talking about hundreds or thousands of containers that you're running? Now, this is like a snapshot, a bit of a smorgasbord almost, like a taster of the problems that you can have with container security. Let's take a slightly more, let's say, comprehensive approach. And I consolidated this from a couple of documents and experiences that people have. So this is consider this as more of a threat model. First of all, we have image provenance and quality. Then we talk about management of credentials and secrets, resource management, isolation, governance and operations. Now let's dive deeper into each of these. Image provenance and quality is how do you know that the containers, the stuff that you actually run, is not hacked or owned or backdoored, and that there are no vulnerabilities in the components in there. And the controls that you can apply there, of course, are use only official images from trusted parties, or better, the ones that you build locally, even though that's harder. You'll also need adequate management of whatever accounts there are in setting up this whole process of getting from source code to running code, running containers. You'll also need some kind of tooling or process at least to make sure that whatever it is that you're depending on, the upstream versions of stuff, that you know about it. And as you implement this stuff, you may also want to scan images for vulnerabilities. Because there will be vulnerable code sooner or later in your application. Moving on to the next area, credentials and secrets. We're talking about massively distributed systems here, lots of which is provisioned in an automatic way, and these components have to talk to each other in a protected way. So there will be credentials and keys that are essential in the interconnection between the many components. All of this you want to set up automatically, but how do you do that in a scalable way? This is not trivial. There are secrets after all. So how do you do that? Well, what are the types of controls that you can apply here? Well, first you need some kind of security architecture that through which you can limit the exposure of secrets, and there are a couple of errors that you can make here. And it will probably rely on some kind of key management system. Now that also has to be architected properly, which means that the components should be there, the components should be secure, the components should have the proper permissions and not too much, not too little, and so on and so on and so forth. And maybe the simplest thing to do is make sure that you don't have any hardwired secrets that live in registries or repositories or in source files, the hard-coded passwords. That is so 1999. Moving on, we can talk about resource management. Now, we talk about supporting highly scalable environments, and we're talking about massively scalable, from things that run every hour to things that run with thousands and thousands of containers. Then that has many risks, and in both directions. Is it too much or too little? Do you have enough resources to deliver any service level commitments? That's a hard one. At scale, that is. You need to think that really through, you need to measure, etc., etc. We'll get to the controls in a second. And is the cost of these resources okay in relation to the benefit that you provide? How much over-provisioning do you have? With resources, we're talking about CPU, memory, bandwidth, but also port numbers and IP addresses, as we've explained earlier. Those are a shared resource within a Docker machine. Types of controls, quotas on basically anything based on physical, logical, whatever unit you have. And of course, measure, monitor. The modern word for this is telemetry. It's actually a recycled old word, because telemetry in 1969 meant mobile data, as in radio data. Going on to the next area, isolation. So isolation is about how components are separated or not, as the case may be, but from each other as well as from bad guys. And this is both on the access level, so can you access source code and can you access data, but it's also about resource consumption. Can you prevent one component from overcommitting or from overutilizing resources, starving one of the others? So there's a link with resource management there. The isolation is between containers as well as between networks, so it works on many layers. Again, controls, network segregation, as in hypersegregation, operate the entire architecture on a need-to-know basis. If two containers don't need to talk to each other, it should be impossible. You have your encryption that isolates data. You have to harden the machines, both the containers and the physical and the virtual machines on which that runs, to isolate that from vulnerabilities. And you may also have something on the policy level that says, well, I want to limit the set of applications that run on a pool of machines. So two different applications may run on the same pool of hardware only under certain conditions. And maybe I don't want to have two vastly different applications run on the same pool of hardware. One of the things that you probably want to do is create a separate pool of stuff for development and testing purposes. I mean, it's too easy to do, and it prevents any resource problems in the development environment from spilling over to the production environment, other than even if those environments are really similar. Then finally, governance and operations, policies and procedures. More and more we see containers as enabling the integration of development operations, DevOps. And beyond that, DevSecOps, where we even integrate security in all of that. This requires a lot of moving parts, and it requires a lot of collaboration between people and a lot of new level of collaboration. It also enables new forms of separation, but that's another interesting topic. Example controls here are obviously the right amount of tooling and automation in the development process. Everything that's manual is not scalable. You will need proper service level agreements and management of that on external service providers where you have stuff. I mean, are you getting the stuff that you order, and are they doing the things in terms of security and protection that you require? And actually, this is not just external service providers. This is also with internal service providers, whether they be hardware provisioners or API providers. You will have to do implementation of patching and updating processes. Now, this should be a natural outcome of a well-tooled DevOps process, but bear in mind that your objective could have different ambitions. For example, it will be easy to redeploy a piece of software, but what happens if you have to redeploy that piece of software to a completely different container platform? That is also something that you would automate. Speaking of which, you want to automate testing procedures. Any kind of testing. Testing should be, by design, should be automated. Test-driven design is one of those ideas that comes to mind. And if you extend that into security testing, you are on your way to become a very mature provider. Okay, wrapping this up, there are a lot more resources. Many vendors now have Docker security tools like agents that you stick in your container deployment that will help you assess the thing in real life. This is way beyond what we can discuss right now, but there is a maturing market out there. When it comes to, let's say, more threat and control frameworks, there is the Center for Internet Security benchmark series. The Docker one is pretty good. You can see the link here. How do you get there? And then there's the Cloud Security Alliance's working group on this, and they have produced a paper that also includes a lot of risks and controls and a little bit more discussion of the background than the CIS benchmark. The CIS benchmark is probably a little bit more, let's say, easier to implement, so to say, because it's like line by line activities. The CSA working group paper is a little less prescriptive, but has more background. So probably relevant to have a look at both of them. And that wraps up container and container security.